Okay. Hello, everyone. My name is Joshua Moore. I'm a PhD student here at Mississippi State University. I've been working on OAIC project for a year or two, roughly, as a developer, implementing new xApp, providing the code that runs the infrastructure, etc. I'd like to thank Pratik again. These cloud native ideologies here are actually fundamental to understanding the impact of ORAN on the reliability, the scalability of the radio access network, and the added intelligence of ORAN itself. So it is directly related to the benefit of ORAN. As we transition here to the hands-on session today, I would like to take around 20, 30 minutes to make sure everybody's set up and ready to go for the hands-on session. Now, I know before you received an email regarding the bare metal setup specifications that you would need. I'll quickly go over those. And then as an alternative here, we've published Google Cloud Platform setup in case you want to leverage Google Cloud today. We won't be using any USRP hardware. So, of course, this can all run in a virtual machine online as well. And another thing to realize is all throughout the room today, as we work together to install this, there are people that are trained to come and help you. So if you have an issue, you can always just raise your hand. Somebody will come and assist you with whatever troubleshooting steps you need. Okay. So if everyone can follow me, and you can either go to the GitHub, which you've received the link to, or you can go to our website, which is openaicellular.org. As you can see here on the top right of the ribbon here, we have published a page, second to the left, titled 2024 Workshop, which has your itinerary for this week's workshop. And also at the top of the ribbon, you can see that we have a section called Code and Doc. So I can just navigate to code here. And this repository is going to be the main repository, which you'll leverage the OAIC platform from. As you can see, we independently manage core components of this platform through submodules. That allows us to debug issues with certain component and push those to those repos. And then once you clone this, we'll pull in all of those modules that we actually need to run the platform. Pertinent to getting you set up for the hands-on section, we'll navigate on the right, top right here to this link, which will bring you to the documentation that I'll use for the hands-on session and you'll be using all week. So as alluded to in the introduction to OAIC, it's divided in section here related to the background information that Pratik just went over, explaining the Docker Kubernetes. But you also have more in-depth installation procedures that'll be generally available even after this workshop for the near real-time RIC and other components. And as you can see in line here to the installation of these components, it actually tries to, you know, incite some knowledge upon yourself, like give you some background upon what you're actually doing instead of just copy and paste here. Here we have the different xApps that are offered. Of course, there'll be more coming in the next release. And then here under additional features, this is a good section to understand because it gives you some like good troubleshooting tips on if a pod isn't in the running state. You can refer to this, for instance, in the kube control commands. And it also explains additional features of SRS. For us at the bottom here, you can see that we've published our day one items here, which include at the top here, if you don't have a bare metal setup today with Ubuntu 20.04, we recommend 6 physical cores, that's 12 virtual CPUs or threads. and somewhere around, 16 gigs of RAM is probably best, but more if you have it. But you can follow these instructions. I'll kind of briefly at a high level go over this because I'll be leveraging the Google Cloud Platform from my computer today. And like I said, anytime, just please feel free to raise your hand, and maybe the ones that are going to assist attendees here can raise your hands so they can see who you are.
Yeah. So I'm
real
one of
quick.
the supporting people. We got some more supporters back there. At any time, if you have a question, you can't find the link, your Wi-Fi dropped, just put a hand up. We would love to help you out, and just let us know how we can assist you, make sure all this works for you. And we'll be just kind of wandering around the room.
Yeah, thanks so much. So under the day one secure slicing, you can see these minimum requirements here under the prerequisite section. So if you're just now provisioned on a VM or on the Google Cloud, you'd want to make sure that you at least have these minimum specifications. Ubuntu 20.04 is a must for this demonstration. So I'll go ahead and open this link in another tab and kind of go over kind of at a high level how the Google Cloud Platform can be leveraged for this demonstration today. I generally find that like as I'm working on OAIC and leveraging the platform, it's best to kind of have the documentation up in a window on your left or your right, whichever you prefer. And usually I'm working in the terminal on my right where I can execute commands here. And these instructions for the Google Cloud Platform setup are written in the same ideology here. So we chose Google Cloud Platform as the example cloud platform. Of course, you can use any cloud platform that you like. I know AWS, for instance, you could leverage an EC2 instance that's a bare metal VM. Whatever cloud platform you do choose, we do ask that you choose a bare metal VM that you do have kind of on-demand access to here. So I'm already logged in here. And I do actually have a VM already provisioned for myself. Of course, if you're just logging in for the first time, you'll go through the sign up process. They do give you $300 of free credits if you're a new user with your email. And maybe I'll quickly turn my ad block off here so I can load this JavaScript on this page actually. Sure.
Yeah, so now you just run directly in the machine using cloud, obviously. We have at least one person who like created a VM, deleted it, and now it's not letting him re-register, so find another email address. Let us know if that works. So, again, if you have any problems, let us know. We'll come around and help you out.
Oh, sure. Yeah, you want to go ahead? Yeah, sure.
So apparently there are different parking spots here, right? And you want to make sure you park in the right place. Where you should park is commuter east on this side, right? Then on the back side of the building. If you park in front of the building, across the street, is wrong? Wrong place? It's the wrong place. If you park across the street, maybe you should go get your car and park behind you.
Okay.
It's not okay. It's not. So let's do the parking now. Let's do the parking now. We do a quick break and then we continue. And these gentlemen can guide you to show you over here.
And on a side note, For anyone who hasn't had a chance
No, it's
to
okay.
grab a name tag or get registered, we do have
Yeah,
some
I
name
almost
tags
texted
over
me. He
here.
said
We'd love
it's
to get
like,
to know
but
you
they need to
from
do it
where
now.
on the right side. We have some refreshments in the back. Restrooms are just down the hall, so please make yourself comfortable. Again, anything we can do.
Yeah, great job. Good. Not a lot of people here.
As long as
It was an E2, but I made it all Yeah.
Yeah, sure. Hey.
I got 2204 on here, so I'm trying to do the
Oh, good.
Google setup,
Yeah.
but there's a whole bunch of this stuff. Sorry.
Yeah.
Um,
Yeah, it'll just kind of ask you for a credit card, and it doesn't charge you or anything. It verifies your identity with the credit card, I guess.
I got you. Okay. So it's asking for my full address. What is it?
Yeah, it's a lot. It's Google. Oh, okay, sure. Sure. Okay. Sure, sounds good. Yeah, it should. Hmm. Yeah, I think it's good. So, yeah, it should go smoothly. We prepared, so. Yeah. I don't know how many participants we have here on Zoom. Yes.
So does it make sense for you to start the first hour somehow? Start something?
Yeah, I think so, because I have some introduction to what we're doing and everything, so.
Do you have a good point to pause?
I think so, yeah. Yeah, I'm not too worried about that. Can you hear me on the Zoom session? But you can hear me well and everything?
Probably, I didn't check.
Can you monitor the chat and try to answer questions on Zoom as well? Thank you so much.
They tested in the morning.
Oh, good. Yeah, we have to, yeah, I'll speak up more. We have to charge this when we go to lunch, they said. Yeah, they said it would die if we don't, actually. Only for that other room. Yeah, there's only one for each room. Yeah, I really like this room a lot. Yeah, these are identical. 2080 and 3080 are identical. I think it's one of the nicest lecture halls on campus, actually. Mm. It's always hard to sleep the night before these things, you know what I mean? Not really. No.
You have to do this cloud-based.
No. Yep.
I just went to the bathroom and shop what are we doing?
Yeah, sure. I'm just making sure everybody's set up and ready to go for the hands-on session. So you either need to,
Yeah, so I found the problem with this Google Cloud stuff when I tried to
okay.
in the public basically is that like the required course are 24, right?
20.0. Oh, yeah.
But the problem is the Google doesn't give you a quota.
Yeah,
So
it's,
you just
It's based on your availability zone. So if you can't get the required resources in this availability zone by default, you can switch to another availability zone.
Yeah, but it seems like the maximum limit for new account is 8, no matter which zone you are. You need to.
That doesn't seem to be the case for us because we usually provision 24 cores.
Mhm.
So there might be some restriction on your account or something.
Yeah, I have to use my own AWS stuff.
Yeah, you can use AWS or any other cloud platform that you
Yeah.
choose.
Yeah, but did you try for new account like?
Yes. Yeah, mine's a brand new account other than today. Like, yeah, there was no
Which zone are you testing?
US East 1A, which
And
is
it gives you
Virginia, I believe.
And it gives you 24.
Even more. I think I can go up to 48 cores.
That's weird. I tried before, but they say I have a limit of 8.
Hmm. Yeah, I don't know. I would just use AWS. It'll be just as good.
You laptop is this Friday, right?
Oh, yeah, sure. Sorry.
Here, I'm looking for this.
Yep.
Um,
So, yeah, it should be there, but also you can always go to console.
oh, and console.
Yeah, oh, you should be on the right account. Oh, you created a project. Okay, so go there and then click on that link, yeah. And then under here, you should be able to see creative again.
It should be under products.
Yeah, try that. It should be under maybe compute engine, I believe so.
Oh, yep, compute engine, VMs.
Absolutely. So enable that, which is part of it. It's going to take a minute to enable, like actually 2 or 3 minutes. And then once you do that, you can create a VM. Yeah. Yep.
Hey, Josh, what's the name of where you enter the SSH keys? He wants to just SSH. I will check.
Yeah, that's great. If you just go close this, can I steer? Is that okay? Okay. So I usually go down here to the bottom here, and actually it's under like metadata actually. So you go to metadata and SSH keys. But actually I think you stored in metadata actually. So, but this is where you would put it. Yeah.
All right, great. So let's go and edit.
Yep.
Add an item.
Exactly.
Now, do you have an ID.RSA file that you've created? No. Okay, so first thing. Okay, you get one of your calendars.
Mention the sign-in sheet.
Oh, yeah, sure. Absolutely. Where is it? Is it out here? Sure. Sure. Yes.
So basically, that's what I tried.
Yep. And then go up. Go up. E2. Yeah, that's
Yeah.
good.
Or even,
Click here, name.
and the only problem is like,
You need to try this. Are you using free credits or your own credits?
that's free credit, still free credit. That's it, but I have activated the full account.
So let's wait a few minutes and see if it increases your quota. That's the easiest solution to this. I think the only other thing that I can think is you would want to try a different cloud platform, right?
It should work either way, because I can give him access to mine.
Oh, okay.
So we're from the same university.
Yeah, y'all can just work
So I
together.
was just gonna make it a game.
That sounds good. Yeah, y'all can just work together.
Yeah, but that's kind of weird. I tried one yesterday to see how to increase the full.
Yeah, I've not seen this issue, unfortunately.
I've had my group cloud for years,
Yeah.
so I don't have any free credits anymore, so.
Yeah, it should only probably be about $10 for the 3 days, you know? It's not really that
He's got
expensive.
the agreement. If you use it.
Oh, wow, really?
Yeah, because they were like, this is the hourly you pay as you use, but by the way, you must agree, if you're gonna go the hourly, this is your rate.
Wow.
Uh-huh.
I didn't know that. I thought it was
Yeah.
spot, like,
It's on the hour.
as you use,
It
yeah.
is, but though, when you go for it, it goes, this is what your monthly charge will be, blah, blah, because it's enterprise, and they just assume.
That's interesting, that you're gonna keep on using it, yeah. Why would you spin
For
up an
cost
instance if you're not gonna keep? Yeah,
Why would you spend up 24 core instance, not for infrastructure?
exactly, yeah.
But yeah. Do you want me to stand it up? Okay.
That's correct. No, 22, a bunch of 22 does not work.
It doesn't work, yeah. Only 20.
Oh, it's a
That kind of is an issue, but it's more so in like SRS installation. There's some dependencies that they don't have packages for in 22.
Gotcha. Yeah, we got someone 22 on the machine.
It just won't work, yeah. So, yeah, they can leverage the cloud. It'll be faster anyways. No, I think I knew it was gonna take some time to get everybody set up anyways, so. I think it's okay. Exactly. If it goes over, it's okay. Yeah, wow. Well. Yeah, I think so. Yeah, it should be fine. You did 5 minutes apiece or so. Wow. Yeah, I think even if this like took all the way up till lunch, honestly, that would still be fine. Sure. Okay. Sure. Yeah, however. Exactly, yeah, everything else should be good. Yeah, it does, yeah. Yeah, it is. Yeah, I think it's working out well so far. Yeah. Yeah, this is the right room to do presentations and workshops. Because I think these are Wi-Fi 6. Yeah. So as everybody's coming back in, I just want to mention if you haven't signed in on the sheet out here, if you would take this time to do so, that would be great. Does anybody else is there anybody struggling with the cloud setup or bare metal? Yeah, it takes a couple minutes to enable that API. And no, they should already have an ISO you can just select. Yeah, it should be pretty seamless, and these instructions should be pretty good. One thing I'll mention also, although these instructions are good for getting you set up, you can either use SSH from the GUI itself, so you don't have to add your public key to the cloud, or you can generate a RSA key from your terminal and upload your public key to the VM so that you can use all the niceties of your terminal itself. So if anybody needs help doing that, we can certainly assist you with that as well. That's the way I'll be accessing my VM today, personally. And kind of additionally, you won't need it for the demonstration today, but it certainly doesn't hurt. We've provided some general instructions on setting up VNC access, which would allow you to have a GUI in case your demo is highly visual. You want to visualize the data from a GUI. So we can certainly assist you with setting this up from the Google Cloud as well. Of course, if you're on bare metal, this wouldn't apply to you at all. Actually, we did provide a cheat sheet for TMUX. I'll kind of go over that when we start the section, but if you look at these instructions, we do just have that already in there. So like I said, the easiest way to follow along today is going to be to have the documentation on one side of your screen in the terminal. I'll go ahead and SSH into my VM that I've created with Google Cloud. How you doing, Ollie? Another day in the life. Yes. You're on the website on the workshop page. So at the top on the right of the workshop page, here, I'll show you. No, it's okay. So if you're on this website on the workshop page, just on that same ribbon, you can just go to doc, and this will open you up. It's okay.
2004 is the only possible all OS, like 20.
20.04 is the only, yeah.
Okay, AWS doesn't provide 20.
Oh, really? You can upload your own ISO though, right? You can upload your own ISO though, right?
Yeah.
Yeah, just download the ISO real quick and upload it, and that'll be fine, all right? You know what I mean? If you download the ISO of 20.04, you can upload it to your cloud provider and use that image, right? So since it's technically time for the next session, if I could just get a show of hands of who still has problems setting up either a bare metal or a cloud-based setup. So we got one, and then I know he's setting up, so 3. Just waiting. Yeah, gotcha. So yeah, we'll wait a little bit longer, but it seems from what I see, everybody else has their setup ready to go, right? So that's great. I just chose default. What is it?
Extreme persistent SSD and then standard.
No, that shouldn't matter at all. And because you're just using it like today and gonna delete it, just get the best, you know. Right? Yes. Yes. So we're actually using SRS as UE, but what we do is we use the ZMQ protocol to act as the physical channel. So it's basically with multiple UEs, we can use GNU Radio to broker the connection between those multiple UEs that are connecting, and that facilitates the transfer there. We'll actually be using GNU Radio to broker the connection between 2 UEs that are connecting to SRS RAN today in this virtualized channel. Yeah. Yes, of course. Yeah, the APIs are all REST APIs for the different interfaces. Yes. No, not necessarily. Like Pratik alluded to, kind of there's a foundational knowledge of cloud native ideology that you should have to kind of understand this. We don't really provide like description of like, you know, what protocol is used with the E2 interface or.
design a xApp,
Mm.
then for data that E2H sends, that's something.
Sure, I'll make it very clear in the demonstration what data is being transferred over the E2 interface and gets sent to the xApp and gets used. I'll make it very clear of that data. Yes, of course. And while we wait for a couple more minutes, does anybody in the Zoom chat have any issues with getting set up if they were planning on following along today? I can go ahead and answer those questions while we wait.
And if I could, briefly, a couple people ran into this issue where they weren't able to create the account under Google Compute Engine, but changing email addresses seemed to do the trick. So we've had at least one person, another person's trying that. So again, if you run into that, that's our current solution if it doesn't allow you to create a VM, period.
Awesome. Yes. Well, so you don't need to do this unless you want like a GUI for demos that might want do that. My demo, you don't necessarily need that.
I got you.
Um, yeah.
I guess control C editors then.
Yeah, sure. If you have your like your SSH in.
Yeah.
Yeah. Yeah, so that should be fine.
Okay.
Like I said before, I prefer like I put it in my terminal by uploading my SSH key. You don't have to do this.
Yeah.
Their terminal is pretty good in the web, but yeah, that should be good to go. Maybe you can just do a sudo apt update just so you can sync the repositories. Sorry, everyone. We had some internet issues within the room, so hopefully that's back working now and we won't have further issues. Um, it's built on top of NextRAN, right? So what it's going to do is it'll facilitate the slicing of the users. It'll calculate the share and send a control message through the E2 agent to the RAN. And that'll influence the scheduler and scheduling those resources based on those quality of services. So the reason we call it secure slicing xApp is because in literature, it's been demonstrated that this infrastructure is vulnerable to these flooding attacks, this overwhelming of requests from the user's context, right? So it was envisioned from Dr. Sabri here at Mississippi State University that we could leverage the ORAN architecture to protect the RAN against these flooding-based attacks or overwhelming requests from these users, right? So, and that's primarily what we'll run is a demonstration of how this secure slicing xApp autonomously takes actions to assess the KPMs of these users that are connected to this RAN and make decisions to secure the RAN from these flooding-based attacks. Right, and this is further broken down. These interactions here within the secure slicing xApp are further broken down in this diagram, where you can kind of see when the xApp is onboarded, it'll start collecting the DL bytes or the KPMs in general from the RAN. It'll assess those, and if it's above, in this scenario, above a certain threshold, it'll go ahead and take the action to unbind it from the slice that it's operating within and bind it to a secure slice with limited to no resources, right? Effectively trying to disconnect it from the network, right? So, and the way we'll do that will become clear, but we'll use a service level agreement of 10 megabits per second for each of the 2 users that we're serving here. And we'll use an open source tool to exchange more traffic than what they're provisioned to have. And this way we can say that, you know, this user is acting abnormally, and we can secure it and take those actions. And we don't do anything manually. Once we onboard the xApp, it does all this for us, right? So like I said, we'll go through these steps here. As you can see, the numbers are the steps that we'll go through. So we'll start by installing the near real-time RIC. This is the OSC RIC that was alluded to earlier. We're going to be using the e-release of the OSC RIC to install this. And then we'll go on to compile SRS RAN from source because it's modified with that slice-aware scheduler, as well as we'll add into the compilation these bindings for the E2 interface. So it successfully subscribes to those functions over the E2 interface. Next, our secure slicing xApp will have to be built into a container so that we can onboard it into the near real-time RIC's context. We'll use Nginx to post the configuration file, grab that, and onboard it into the near real-time RIC. And then lastly, we'll deploy the secure slicing xApp, and I'll show you how this autonomous process happens of securing the RAN from those abnormal users requesting many resources, right? So is there any questions on what we'll do like right after lunch? Yeah, sure.
Yeah, just what kind of KPI, how do you know? You have two users, what is like 10 megabits. So what do you monitor to tell you that this guy put in more? Because usually in this thing, you have somebody that was trying to flood the RAN by the state. How do you detect that?
Sure. So exposed to us with this is a lot of metrics actually. So we have DL bytes and PRB allocation to each users and TX packets. And in this case, the TX packets from the user's context is what we actually look at to see, you know, how much information is the UE trying to send to the RAN, right?
So do you actually have access to the number of PRBs that you allocate?
Yes, we have many KPIs. I think it's around like 20 or 30 KPIs that we actually have. Most of these are the standard KPI mon KPIs, but we've extended those as well. Of course. Yes.
Let's say, but this is different. Let's say, so you don't have the user there, but you have someone who's not supposed to be, but he's just trying to access the network.
Mm. Mm.
Does this fix that?
This assumes that they have already been authenticated, right? So this is a core network that wouldn't want to authenticate this user, right? Because it has invalid credentials, right? So that would be more of like kind of like a signaling attack, right? Where they keep replaying that. Yeah. So I think it's in the same kind of attack sphere, but this assumes that they have already been authenticated and they have access to that E2 interface. And then over that E2 interface, we try to overwhelm. Yes.
Would we be able to like affect each pod that we needed? Like for example, can we implement like an xApp that works as a admissions control or authentication or something?
Mm.
Like can we keep track of the traffic? Maybe recognize some kind of a pattern, something like that.
I will say, with our analysis of this attack and implementing the mitigation strategy, we did. It is nice to be able to have like a Prometheus server that gives you access to the resources that are running the pods. So actually, we do see that under attack, there is some scaling that happens with the cluster, right, to try to like deal with the influx of resources that it would need to support these users. So hopefully that answers your question. We can see the increase in resources at the container level, yes, and you could certainly have your own container or other xApp service that runs in a container that could give you further metrics based on this. Of course.
We're talking like so it would be possible to simulate some kind of like DDoS attack, right?
Yeah, exactly. This deals with the request from the user's context, but of course, if you could have many users that you could you know provision together and send attack against it, as you know, this assumes that you already have access to the E2 interface, right? So, but yes, a DDoS attack is a valid attack.
They define something something storm, something attack where you have usually a lot of IoTs, and they try just to access the network. So basically,
Yeah, this is a signaling storm attack. This is what I was alluding to earlier. It's different from a DDoS attack, but it certainly is in the same realm of attack, right? We're trying to overwhelm the resources of this infrastructure so that we can try to, manipulate the functionality of the RAN, or, or give ourselves authentication when we're not supposed to, for instance. So, yes. Yes. Yes.
My question is like, this attack sounds similar to,
It's very, very similar to a DDoS attack.
yeah, how can actually that device against when if you have too many attacks?
Mhm. No, it's a good question because before this was envisioned here, you would just not have any action to take against these flooding-based attacks, right? So the idea here is that the xApp would look at the temporal behavior of the users that are connected to the RAN, because once they're authenticated, we believe that they're trusted. But this xApp actually aligns with current ideology of zero trust architectures, right? So we don't want to trust any entity that's already been authenticated. We want to continuously look at the performance metrics or the KPIs in this case and try to make some intelligent decision and never trust them. So we're going to look at the temporal behavior of the UEs. We're going to look at the UEs in regard to legitimate users that we've surveilled before this, and we're going to make a decision at this xApp layer if they're over this threshold to secure them, right? To get them outside of this slice that they're operating within. False positives? Yes, actually, that's a good question. We actually did do an analysis of false positives, and you'll see we actually every 10 milliseconds a KPM report is generated within this. That's based on the service model of KPM. So every 10 milliseconds we get a new report that has both users' information in it, right? So actually we found that we had to have at least 10 reports to be 100% certain that this user was malicious. Because you're right, the channel itself is very dynamic, right? So we can't just say with one report that this user is malicious because the channel quality could be very good at this time, right? So that's and I can show you a figure that we put together with that analysis. It was an interesting analysis that we did. So I think before lunch, one thing that we can do to make it a little bit easier on ourselves when we come back is we can go ahead and clone down all the software that we're going to need to run the demonstration after lunch. This will just be a git clone here. So if you come down below here, there's some dependencies that you can install here. If you're running the Google Cloud, you'll have to sync your repositories with this apt update to refresh those. And if you're using the cloud, it should be very quick. So some of the things that I'm just installing here is Git, so we can clone down the code here, and tmux, which if you're not familiar, is just a way that we can manage terminal windows in a command line only environment. I'll personally use that today because we'll be managing a lot of windows to see the interactions here. If you're on a bare metal setup, it's going to be easier for you because you can just move the terminal around any way you'd like. We do provide a cheat sheet here showing you kind of the basic commands. The ones I'll mostly be using here is creating a new window, which is Control B and C, and I'll switch to a next window, Control B and N, and you can use this to reference. So you'll want to navigate to your home directory. You should already be in your home directory, but all the commands that I'm going to run after this is going to assume that OAIC is cloned into your home directory. This is going to make it easier for you if you do the same because then you can just kind of copy and paste as we go along and not have to change directories based on whatever directory you put. So I'll go ahead and clone down this OAIC main repo here. And I'll give everybody time to do this. I'm going ahead and change the directory into OAIC. And just to show you here, these submodules that comprise OAIC, such as the RIC deployment, the E2 interface, which we'll pull down from a registry we host from, OAICT, everything. There's not going to be anything in these folders really, because these are submodules, right? In this way, we can version these independently. And once you cd into this repo, we actually have this command which will update and pull in all of those submodules that are linked to this main repository. So really, this is the step that's going to take a couple minutes, probably, if everybody does it at once. So you can see it checked out a certain branch of each of these different submodules. One important thing to note is if you're going to leverage the OAIC platform, if you're, for instance, wanting to have your own modified E2, for instance, and you have it on another branch, you can do a ls-la here. And actually in .git modules, this is where everything's going to be linked to, right? So I could potentially have my own local installation of OAIC and change the branch that I want to pull down, right? This is a good way if like you're developing an xApp with OAIC in mind, that you can quickly prototype your own modified branch or code. So now that I have OAIC cloned down and the submodules pulled, I think that's going to be a good place for me to stop, but we can hang around for a couple more minutes before lunch and assist you if you have any problems. And then we can go over to Cimarron and have lunch. We'll come back after that and we'll start the hands-on section of this demonstration.
Later versions, right? So they could change, for instance, the E2 manager version, and they could call this the new release, right? So I'll kind of go in there and show you here that it's just. So you can just see some JSON here, and these are the different services, the A1 mediator, for instance. It'll have a name of the service here with the version or the tag with it, and this is how, like I said, this whole recipe denotes the release of the RIC. And these versions of these services denote the e-release of the RIC. As you can see before, when we pulled down this E2 interface here, and we pushed it to our local host or our local machine here on this 5001 port, this is where it's actually going to look for that service when it deploys all these services, right? So a lot of these are, external to us. Nexus 3 is a repository of services for ORAN software community. You can go and browse the different services and their version. This is their primary repository. Early on, actually, in OAIC, we actually noticed the reliability of this external repository was not very good. So we kind of found that some of these we would need to push to our own repository, or instead we would give you the source code and have you build that out. But it seems that since then, these services have been reliable to pull from these external registries. So am I good to go ahead and move on to the next step, which is deploying the near real-time RIC and all the services there within? Awesome. So again, it's just copy and paste and make sure you're in this bin directory of the RIC deployment submodule. And I'll just copy and paste that, and it'll start this automated process of one by one deploying these services. Right, so it'll pull down the images that aren't local to me, that I don't have on my machine here. And then it'll go ahead and deploy them. So I'll allow for some time for this step, because as you can see, it actually does take a couple minutes for this to run. One thing that I want to show you real quick before it goes away is I'll do get pods dash A again, and as you can notice, usually from what we've observed, that this one E2 term alpha pod takes a little bit longer than every other service to come up actually. So we'll just kind of wait a couple minutes and then get the pods again. Usually this will come up though. You want everything in the running state besides this tiller secret generator, which would run once and be done, right? One thing worth mentioning quickly here as well to observe while we have this up is actually you can see that the namespace is different for these near real-time RIC services as opposed to the Kubernetes infrastructure components. So you can observe that after, just a little bit of time, that this E2 term will also become ready. If after a few moments this E2 term alpha pod doesn't come up, you could just raise your hand because we'll need to assist you in debugging that issue. For your benefit, because everybody here may use the OAIC platform for their research, it seems that with the OAIC RIC, that this E2 term itself is kind of the primary point of failure, right? So there's a step where we'll run the G and B, and oftentimes there will be a failure and we'll have to redeploy the RIC here. So we've noted that in these instructions here, and if it does happen, we'll debug it live here so that you can learn from that experience. Is everybody with me here? Or okay.
So is the E2 term also is the only pod that we need to worry about?
I've not observed failure in the other pods personally. Yes, I think you want to look at all of them and make sure they're in the running state besides the tiller. But
Except the tiller.
except the tiller. Yeah. This runs once and it generates the secrets. This is kind of an authentication here. So. Okay, well, if everybody's here, I'll go ahead and continue. So we'll reference the diagram again because we're actually moving to 2A right now, which is we're going to compile SRSRN with our modified E2 agent. So we'll go ahead and get started with that. So you can see my first step is that I'm actually going to compile my ASN1C this is the encoding that's going to be used on this E2 interface, right? We'll switch to this branch that we use, and we'll use this script to configure this for us. We'll just run make here, and we just specify improc to use all of our cores here, but of course you can change that make ops as you wish. That's not going to take long for this since it's a very small source code. And I'll just use make install. So that should happen relatively quickly and error-free. And we'll use LD config to update our linked libraries now. And I'll just move back directory into the OAIC repo. So of course, this ASN1C provides some protection of the data in transit over this interface. So, you know, this is important. And an important thing to notice is that the ASN1C version needs to match on both ends of this interface, right? So in our wireless community, you'll get pretty familiar with compiling SRS ran from source, right? So, and that's going to be no different from what we're going to do here. The only difference that I want to point your attention to when we compile SRS ran outside of when you would just use it normally is this CMake command that we actually use. We specify our directory for our bindings for the E2 KPM and the E2 SM. These are the service models that we're going to compile into this SRS ran. And when you're looking at the compatibility of different services like xApps and rApps, you really have to pay attention to the version of the service model that you're working with. So this becomes a very important thing to observe here because, for instance, they could bump the version of the near real-time RIC, but make that incompatible with their legacy xApps they offer. So until you either bump that yourself or they do it for you, those xApps will actually be incompatible, right? So. So assuming everybody's with me here, at this point, I'll go ahead and again, I'll just kind of start copy and pasting over here and explaining as I go. One thing to notice here is I'm going to be very particular about copying one line at a time. And then when I get to the CMake, I want to copy this entire block at once here, right? So I don't want to just copy everything in here because usually that causes some error. So since we're using a modified version of SRS RAN with a slice-aware scheduler, it's not actually within the context of the OAIC submodule system. So I'll just go ahead and clone down in the main OAIC repo this SRS with the E2. And of course, it's there. I'll go ahead and just CD into this SRS LTE E2. And this next step assumes that you would have built a different version of SRS before. Of course, I'm not going to have a build folder, a build artifact here, so I can kind of just skip over the step. But if in the coming demonstration in the following days, you'll be recompiling SRS to support their demonstration. Just know that the easiest way to rebuild this is to remove the build folder, right? If you haven't installed it on path, remove that build folder, make a new build folder, and we'll actually export this SRS row path that's going to be used as a directive. So I'll just make the build folder since I'm the first one and CD there. And we'll use CMake to go ahead and populate this build folder. So assuming that everything goes correctly with the CMake, definitely this is something you want to watch out for. You should see a good build files have been written here. This indicates that everything worked properly with CMake. You have all the dependencies. The dependencies are usually the primary issue with CMake, right? You might not have the compiler, GCC compiler or anything like that. So just make sure it says the build files have been written to that directory, and we can go ahead and start compiling. Again, we'll just use that make toolchain, just copy and paste, and it'll use all of those resources to compile this code. Yep. Yeah, so there's probably SCTP dev that's not a dependency. Hey, Wen or Oliver, who do we have available that can assist? Yeah. Yeah.
So the last step it says there's a forced override, right? So why?
Sorry?
So the last step is force.
Oh, I'll come to that. I'll be sure to mention that because that's important. Okay, thank you. Is he not missing lib SCTP dev?
So that's just building the LTE. So the SCTV is not a big of a deal.
Sure.
It should work about it.
Okay. Thank you.
So actually, my make process did fail. Sometimes I'd like to take away this in proc. You know, sometimes it builds too fast. You can do -J and specify the number of, it's supposedly the number of virtual cores. I like to go a little bit under that. Here I'll probably do 16. So as you can see, my make process isn't actually building properly, and there's no apparent error that I see personally, other than maybe this file. So what I like to do in this, one thing that you can do is remove this build folder and try this again. And maybe I didn't export these, maybe that's why.
100% that your laptop has to be read, maybe set up application.
Hmm.
Not literally here.
I don't know.
Let's see if it fixes it.
So those pink color messages missing something, those are okay, right?
These are the compiler kind of warnings
Okay.
that you might want to optimize maybe or something like this. Yeah.
But the red one is what we need to pay attention.
Generally, if it stops, that's bad.
Okay.
Yeah. So it looks like maybe I solved my issue.
Oh,
It's kind of nice that we can debug live. It seems that maybe I skipped this export of the SRS real path.
oh, that line. Okay.
Yep. And it didn't know where to find this header file that I was missing. Right. So this is a good experience for everybody. Yeah, actually. Bless you. So as you can see, you miss one command and it could, mess up every, yep. Can you speak a little louder? I'm sorry. For this xApp, we have some papers that we published about this. We don't really have specific documentation here. We'll provide this documentation here that talks about the interactions of the xApp and the deployment procedure here. But really, I would say if you're looking to leverage this xApp particularly for your research, you probably just want to look at the source code, and I'll go into the source code a little bit and show you that.
Yeah. Also, can you use real degrees instead of
Absolutely. We actually, in the paper that we show, we use real USRPs instead of virtualized USRPs. Yep. Yeah, we're just doing that for ease of use. I would love to support an SDR workshop, but it would be kind of difficult, actually. Thank you so much. Any other questions? Katsu, you can use Katsuis as well, right? This version of that's what's really the compatibility here is does SRS version that we're using with this deployment, does that support, SDR or Katsuis? And in this case, it does actually support both SDR Katsuis.
Does this version of SRS that you're using have a CUD split? Or is it
This is a monolithic, yeah.
It's strictly monolithic.
Yes, yes.
So CUD, are you everything together, right?
Everything together.
Okay.
Yes. Yeah, slicing is going to be interesting with a disaggregated RAM. I'd like to see that. Yeah, so this version actually does have 5G non-standalone release in it, actually. Yep.
But right now we are deploying standalone.
We'll just use the 4G today,
Oh, 4G.
but you could use the 5G non-standalone as well. Yeah.
Oh, so I was gonna ask,
Yes.
this is for the LTE.
Yes,
And if you do 5G, you just replace 5G?
it's just a different binary that you would run, actually. Yep. Absolutely.
So in that case, we are not doing OCOD, we are doing OEMD, is that right?
Well, this code base actually does have the CUND, it just runs in line with the execution of the binary. Yeah. So SRS is kind of, even in SRS RAM project, which is the fully 5G standalone, is the same code base, right? Except they've added the functionality of the new USRPs. So this is good. 100% finished, right? So I assume that this is going to take, especially the folks on bare metal, it's going to take a little bit of time. If you can kind of just tell me if you finished, that would be good. Has anybody encountered any stopping point, any block at this point of installation that we could assist you with?
So this is the, let's not see, so this is the version of the whole, what's referred to as the Geno thing.
Yeah. So actually, we're building both the GNB and the UE now here as well. Yeah. Yeah.
Still not getting it all. This is, this right here.
Yeah, it's relatively non-trivial to use any xApp with any version of SRS or OAI. Really, the point of contention here is, like I said, does SRS RAN project, which is the 5G standalone release, support this version of service model that the xApp relies on, right? And I think that's really the blocker. And then also, since we have a modified scheduler here, that would also have to be ported over to a fully 5G standalone deployment, right?
Scheduled for the resource?
For the slices to slice, yes. 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 Yeah. So, and it's all community built, right? So mostly PhD students are building these technologies out. So. So far you need to kind of be familiar with cloud native architecture, as well as compiling source code from scratch, right? And there's these ORAN, service models that you need to be familiar with that Pratik alluded to before. So it gets a little bit complex. Awesome. Well, am I good to move on from this portion? Awesome. So of course I'll just run sudo make install to push those built binaries on path. It also puts our config files here. We'll update those linked libraries to reflect those new binaries as well, without having to source our environment from scratch. And we had a question about this command. This is a good command to understand what it's doing, because this script that we're running, this config script, we can specify whether user or service. There's a couple of different specifications to this configuration. But basically what this is saying is move outside from my build folder the configurations that are going to be necessary for SRS RAN into whatever service level that I want. So if I'm user, it's going to be under root.config.srs RAN, and those are where your configs are going to be. These configs are the primary interface in which you're going to change your bandwidth, or there's also r.conf that you can specify your MIMO, whether you're going to do 2x2 or I think it's in port 4x4 in this release. These are the primary configs you're going to change for your file there, right?
So we need to force override.
Yes, and when you say force override, there's some default configurations, and we want to override those with the ones that we've set up and automated for you today. So yes, just type yes and enter. And as you can see, it's put in root.config, SRSLT, the different configurations that I was talking about, one for the UE that has the credentials in it, the ENB, and all of this stuff. And then if you notice at the bottom, we actually have our own custom configuration file for our slices. So we actually have a CSV file that denotes our slices that we would configure here. There's another interface that I'll introduce that we can actually slice in real time. So when I'm looking to set up my UIs that I would want to connect to my RAN, I would want to specify the MZ and encryption algorithm and all of these things in this user db.csv, because this is what's going to be sourced to see if it's known to my core network. So it can become properly authenticated, establish a PDU session, and exchange traffic.
You set the security protocols on the user DB and all that.
Yes. So that would be the end of setting up our SRS RAN in this case. If these things completed for you, that should be set up, and we'll actually move on to the next portion, which would be hosting the configuration file locally, so that when we onboard our secure slicing xApp, it can grab that configuration file in the onboarding process and use that to configure that resource. So we'll just use Nginx here on a local port to host that configuration file. This is the most minimal way to host this. So of course we'll just install that using apps. As part of the installation process from apt, it'll actually go ahead and make sure the init system runs that process in the background for us, and we can just verify that with the next command. As you can see, my Nginx process is running properly and active. If you had been previously using a different xApp or service that you had onboarded, different configuration file, you might want to unlink that configuration file. So once that's done, we'll go ahead and make a local folder in which we'll put our config files for the different xApps that we would want to onboard. And that's denoted in these next commands. So for any HTTP-based hosting, Nginx has this default www directory, and we'll leverage that by creating a new directory within inside that www called xappconfig.local. And we'll go ahead and move into that folder. And we'll go ahead and make a directory for our config files that we'll move here. So to properly leverage this directory for configuration files for xApps that we would want to onboard, we actually need to configure Nginx to look at this directory that we just created. So that's what we'll do in the next step. It's a little bit of boilerplate code that we can just more or less put in here. So if you navigate to this etc nginx conf.d, I'll use Vim today. You're welcome to use any text editor you like.
On a side note, if you're not a Vimy person, a Nano or Pico is my favorite. And if anyone wants me to walk them through Nano, Pico, I can help you. If you want me to help you with them, then don't find somebody. So
Yeah.
seriously, if you want text editor help, we can.
Yeah.
And
Thank you.
And if you have VNC, then you use Geo.
So once I open this in whatever editor that I would like to use, of course, I'll just copy this entire block here and make sure I don't miss any of the opening or curly, ending curly brackets here. And sometimes it'll actually cut off the S of server, so just watch out for that, verify. And I'll just exit Vim. Saving those changes. And again, we're using Nginx because we have a config file. We want to make an HTTP request to take that config file and use it when we're onboarding our service or our xApp. And Nginx is the most minimal way to do this. Yeah, go ahead.
Yeah, if you have your own xApp, you have to have some way to host your configuration file. And let me go ahead and while I'll kind of wait for a minute for everybody to get here, I kind of want to go in this config file and show you what a config file even is for an xApp, right? I think that'll be very helpful. So to do that, I'm going to launch a tmux so I can keep my place here. I don't want to lose that. I'll create a new window. And I'm going to go into OAIC. And we'll use our KPI mon xApp, which we won't demo in this workshop. But just for demonstration, I'll go into its config file.json, right? So JSON, very common template here for us to look at and very readable as well. So you can see that what you want to do is you want to associate the different services or the service models that you would subscribe to for this xApp to function properly. So commonly, you would have the KPM service model that you would want to subscribe to, so you have some metrics from the RAN. So yes, if you, for say,
create your own xApp to do X, you would need to make sure that functionality is subscribed to within your config file. And usually when I'm looking at, do I want to create a new xApp, I'm probably going to take this template and replace the name of KPI Mon with mine. And if I'm using common services, I'll keep that, etc. No reason to reinvent the wheel. But yeah, very good question. And then also you can see down here our RMR route, which will exchange traffic for the different services. You'll have to have the container that's running in and the port number that it'll exchange traffic to, etc. So, yep. If you create an xApp, you have to create your own custom config file to support that xApp and its services. So we can check against any syntax errors that we may have made by just running this next command, which is built-in argument to Nginx. You do want to run this with sudo so you can properly test this, and it tells me that, hey, I have not made a syntax error in those 4 lines of code. So that's good. So any errors that you have, just please raise your hand. So before we start installing the SSX app that we'll be demonstrating today, we actually do want to modify SRS a little bit to know about the identification of the 2 UEs that we're going to be connecting today. So again, we'll modify this user db.csv. And of course, we'll create a network namespace for these different UEs on our terminal. Those, of course, have different MZs, which is right after this authentication algorithm. You have OPC and K. These are other mics on. Oh, thanks.
Can you quickly check if it's good? So, yep, thanks. So yeah, we'll just edit this user DB CSV to know about these different UEs that we're going to connect. We'll connect 2 UEs today to this RAN. I'm just in this config folder. I'll open it with whichever text editor is best for me. And you can see some UEs already exist within this user db.csv. I'll go ahead and just delete those UEs and replace them with the values that are given here. So I want to make sure to explicitly copy everything within these blocks. And once I paste that in here, I want to make sure that nothing was cut off, of course, right? if I wanted to have 10 virtual UIs here, I would keep adding with different MZs here, as long as those are known to my core. Yes. MZ, yes. International Mobile Subscriber Identity. Yeah, this is. It's actually here, so it tells you the order. So you have your name, authentication algorithm, MZ, key, which is another authentication mechanism, right? OP or OPC, this is yet another authentication mechanism. And you'll have your AMF address here, and so on and so forth. Generally, if you just want to have these virtual USRPs like I have, I'll generally just increment the MZ by 1 and let those be known to my core. So all the other stuff can generally stay the same, right? You can also, at the very end here, one thing that I like to do personally is you see it says IP allocation here at the very end. Within your DNN, you can actually assign a fixed IP, a statically assigned IP to each of your UIs. This is very helpful if you don't want it to be dynamically assigned to you. You know, your optimization might need a fixed IP on this UI every time, right? So you can just put in 172.0.16.1 and it'll always assign it that address. Yeah, it's a string, right? So yeah, you would put it in. So that's helpful. In Open5GS, it's a little bit different than this, actually. You assign a DNN pool, and then it gets assigned over that DNN pool. So I've successfully exited Vim now, and I'll go ahead and exit root as well, because I don't need to edit anything else. Yeah, please. Which one? When I edited, you want me to go back up? Yeah, so I'm going to connect 2 UIs for the demonstration today. So the user db.csv denotes which the authentication and the identification of the UIs that I will connect, right? So this is how I let it be known to my core that I'm about to connect these. Okay. I did modify, yes. So there was some pre-existing UIs in here, and I deleted those and I added the ones that I have here, right? So there was pre-existing values here. I deleted those, and I copied and pasted the ones I provide you here. Yes, because I specified user, and I ran sudo before that, right? So then I'm effectively the root user, right? Yeah, it's a good question because I myself have used SRS's automated configuration installation script that we ran there to actually script out the automation of other configurations that I would want to do as well. So you can extend that script and use that as kind of like, I don't want to write my own script. I'll just use theirs. right? So that's one thing that I've found that's helpful. But it's just a bash script, so. Awesome. So who's with me? Everybody with me? More or less?
I keep running into issues where and it's probably a Google problem, but the SSH in browser keeps closing.
Oh, so maybe what we want to do instead, if you can generate your RSA key and upload it, you'd probably be a lot more reliable that way. Would you like me to show you quickly how that's done? So yeah, so at the very bottom left in Google Cloud Platform, there's a metadata section, right? And
Oh, yes, in the settings, right?
exactly. So in metadata,
Yeah.
I can upload my SSH key, right? So all you want to do on your local terminal is run SSH-keygen, and then it's going to generate a key value pair, so a pub key and a private key. And all you need to do is upload your public key. And at the end of your public key, if you'll take away your name at your local machine, instead just put your name, that's the username you'll use to SSH into your VM, okay? SSH-keygen, and it'll by default generate a RSA key. This is enough encryption for now, you know what I mean? No, there's no space, right?
Oh.
It's a command, yeah.
Just like that.
Absolutely, yeah. And then it'll say where do you want to save it and etc. Right. Okay, since everybody's with me, I'll kind of continue for the sake of time here. I've exited after updating my user db.csv. We'll go ahead and move to the next section, which I'll reference this diagram very quickly, which is number 4. We'll start building our secure slicing xApp into the container that then we will use to deploy the secure slicing xApp from. So I'll CD to my home and then back into OAIC. So I use that common directory structure to keep everything organized. And I'll go ahead and copy and paste. As you can see, it's not going to take but 1 second to clone this down because there's actually not a lot of code here. This is all going to be built into what becomes a larger code base, right? So now that I've cloned that down, obviously I just want to CD into that directory that I've cloned down. As you can see here, let me clear this and put it at the top so you can see it easier. Of course, we do have the configuration file that we'll work on now and putting it in that nginx directory. We do have some data collection parser scripts that we've written. We do have the broker, the GNU Radio broker that we've generated. And then also, I'll talk about these files as we go. So I'll just copy this next command, and as you can see, all this is doing is copying our config file.json from here, and its destination is this original config files directory that we created in the previous steps. So it's just going to copy it over there for us. Nginx should be refreshed so it knows that there's a new config file in the directory that it's pointed towards. So we'll just run the next command to use our init system to reload that process running in the background.
And since we have a Docker file specified here with our build directives for the source code, I would rather it build inside that container. So we're just going to use our Docker build in the current directory, and then we're going to tag it here so that it knows where this SSX app is going to be. So all the CMake and the make and all that stuff is kind of abstracted away for us. It happens automatically due to the Docker build. So the Docker containers for these services is obviously a nice thing, but it adds a little bit of complexity, as you can see later on in the demo, because when we want to get any input or output from this xApp, we actually either have to set up our own login mechanism and open a port to this container, which we would, then read the logs from. It's a little bit more complex than an app that would run in your local state. Obviously, there's a lot of nice things to building it inside of a Docker container, hence the increased portability of the xApp itself. Supposedly, this should run on anything if it's a Docker container. In my experience, that's not really the case. So while this is compiling and everybody gets to the step, I kind of want to explain the internal workings of this xApp a little bit more for you so you get a full picture of what's going on here. So as we stated before, this is built off of NextRen, and the original idea Dr. Abdallah had for the security of the RAN from this xApp. We built on top of the NextRen, so we didn't have to start from scratch. And this is a good figure to explain the interactions that happen here. So what we have here is we have our SRS RAN here, the core network and the eNode B with the CU and DU. And then we have our OSC RIC here. And of course, as I alluded to, we are using the KPM service model to extract metrics from our RAN. Those automatically go to our xApp. And also we have this custom slicing service model, a product of Powder Lab in Utah. And as you can see, the primary interface to interact with the slicing component of this xApp is through a northbound interface at the top here. So they have published a northbound interface, and they use a library called Pistache to facilitate this minimal JSON interface to where I can use curl requests to update my slices by myself, and that's the interface there. So I want to show you quickly how I would run a different slicing configuration. And actually, as the xApp is running, I can update the slices, I can unbind slice, so I can rebind. This can happen externally, and there's actually an internal messaging infrastructure that they have that we've extended for this custom functionality as well. So in the same SSX repo, I'm going to go in with my text editor into, we've made this ZMQ2 UE for this demonstration today. And you can see all I'm doing is exporting SSX app into a variable in my shell. and I'm using kube control, again, these microservice based ideologies to get this port and IP of which I would want to send these commands through, right? So whenever I, for instance, list the active node Bs or the slices or the UEs that are connected here, of course, it's just a minimal curl request, a get or a post. We'll use this IP that we've extracted into a variable here, and whatever port this is hosted on. By default, they have the northbound interface set up to port 8000, which is a common interface to host this kind of interface on. This is automated, so I'm going to use Python, and this is going to go through this automatically and provision these slices for me. And like I said, it's based on the scenario. So we have set up a fast slice here, where we'll bind both of our two UEs. We'll use iperf in an argument to simulate abnormal behavior from one of the UEs that's going to operate outside of its SLA. But this is where the resources would be configured for the slices. And as you can see, we're just using that MZ number to identify which UE we would want to associate with these different slices, right? So this was Nextran. They did this part, and we extended on top of this for this secure slicing. So as you can see here, my Docker container successfully built. Before we move on, I'll just quickly check if everybody is here with me and hasn't encountered any blockers. We can certainly address those before we move on. After a couple more steps, we're actually going to be into the section of the demonstration where we'll be running, managing windows. This will move very quickly, because once we onboard the xApp, it's automated. It's going to do its thing. So I have to show you very quickly, right, the process. So I want to make sure everybody's. Yeah, sure. Actually, we haven't gotten to that part yet. I'll go over that part right now. So let me go back to our secure slicing xApp instructions here. And I had just finished building the xApp here. There we go. So yeah, that's the next part actually, and everybody has built this container that's following along. So yeah, I want to this onboard URL file is going to point to the local address where the config file is being hosted by Nginx, as you can see in this command here. So I actually need to replace this machine IP template with what my cloud VM has. So what you can do here is you can either use hostname-i, which we've specified here, and the IP that you're going to want to use is the first one that returns. This is your IPv4 address, and you can copy that into your clipboard. Let me make sure I'm still sharing here. And that's the onboard, the IP of my VM, IPv4, is copied into my clipboard, and I want that to be reflected in this onboard URL. So I'll go in here and replace the machine IP address with that IP that I've just copied. Just like so. Sorry? Yeah, sure. Yeah, I just opened with my text editor this onboard URL, and I pasted my VM's IPv4 address in there, right? Dr. Tripathi, I'm sorry, it keeps Zoom messing up. It might not be so good, for the online participants.
Yes, I can see.
Oh, you can see it? Okay.
Yeah.
Yeah, it keeps going out. I'm sorry.
No, but I can see, no problem.
Sure. Since we have a moment, is there any online participants that have any questions? Yes. The web server Nginx? No. So actually, we need a minimal web server, and we use Nginx to host the config file because we want to make some HTTP request from our Docker build process to pull in that config file, right? Essentially, it's it is a JSON file. So yeah, we're just hosting it, and HTTP is the most minimal interface that we could use to get that back from a curl request, right? On a local host. Yep. And then it pulls that in, right? Yeah. You're absolutely right. And obviously you can host this file in GitHub or whatever you want to, you're right. This is the way that ORAN software community has done it. And it's a minimal way and an elegant way to do it that I quite like. When you get into, for instance, we could mount a persistent volume with all our configurations if you had more than one configuration for your xApp, for instance. But then you would have to facilitate that in your Docker build process, right? So you're right. Of course, all this can be modified at your leisure. This is just a minimal way to host this file. Yeah. So it's installed, and we're going to run it in the next section. It's installed in the SRS build process itself. Yeah. Yeah, we did configure the UE to be known to the core, so we have actually modified it. Yeah. Yep. So is everybody good on this step? Awesome. And this is again where we start to run the demonstration here. So like I said, there's some interactions that happen that I have to quickly show you while they're happening, so that you see the interaction that happens. I'll kind of demonstrate this. I hope you can follow along with me. I'll kind of explain it as I go along. This is the starting of this core network here in the first step here. Before I execute any of these commands, personally, to manage all these windows that we're about to be managing, I'm going to use tmux. We've provided, again, a cheat sheet at the top here that you can reference if you want. If you have a GUI, it's probably a little bit easier because we'll probably have like 10 or so windows that we're going to have to manage here. So what I'm doing here is I'm creating a network namespace in my terminal. This will give me some logical separations since we're using a virtualized USRP. And I'll use this third command to list those UIs that we just created. This is a logical separation here. And then we can go ahead and start that core network here. I'll create a new window with Control B and C, and it'll automatically swap to that new window where I'll go ahead and export some variables. So namely, to do with this E2 interface, we'll use these commands to automatically extract the IP, the port of this E2 term interface. And that way, in the subsequent command, we can use these dynamically to know the IP at the end here. One thing to note with this, the way we're running this ENB is we're actually specifying runtime arguments. This is a good way that you don't have to edit the configuration file every single time to facilitate whatever you want to do. I'm pushing all my logs to std out so I can have an indication of if it's running properly. Like I said before, this is the common failure point of the OSC RIC in general, is this E2. So our ENB is going to get an E2 setup response, right? And if that fails to be decoded or anything, then we actually have to debug that. Usually we'll have to redeploy this RIC. Hopefully that everybody, it doesn't happen like that. So I'm just exporting these variables into my shell environment here. Notice that I don't want to change over to a different tab or anything because it won't preserve these within tmux. And then one more thing to note here is that using this virtualized channel with ZMQ, I actually have to specify my TX port and RX port. And this will have to be mirrored in your GNU radio flow graph, all right, to broker this connection. So I'll copy this whole command here. So it looks like mine went successfully, which is great, right? I was sweating. So it actually decoded successfully my E2 setup response, and this is the RIC state that I want to see before I move forward past this. Did anyone not get the RIC state to be established right now? Because this is when we want to employ all of our help towards you. Everybody's E2 set up. I can't believe this. It's good to go? Oh, great. Oh, yeah. Gotcha. Did you restart your core network? Probably not. I would say Control C your core network and rerun the core network because it probably already thinks that MZ is already admitted and it doesn't want to readmit that MZ again. Yep. And if you need any more help, any of these guys can come help you. So anybody with a E2 setup failure, RGB P mask, printed message,
I've seen all kind of errors at this point. Am I going too fast? Should I slow down? Everything good to go? Awesome. Well, if that's the case, I'll continue the demonstration. Fantastic. So I'll leave the RAN running in this window, and I'll make a new window. And I'll move on to connecting the UEs here. So that's my UE1. You can see that it's going to wait to initialize because I need to run that GNU Radio broker. I'm going to create a new window after this. And you can see that I'm specifying that this is UE2. And also this one is going to wait for the PHY to initialize. And this is the part where I will run this GNU Radio flow graph. I've generated it without a GUI dependency, so we can just run it inline here in the terminal. So we should already be in this directory that we're going to run it from. And you can just run Python 3 with the 2UE, for instance, in this case. So I'll kind of cycle back. You can see that it's updated with the new users that are connected with their TIMSI. It's assigned an IP address to each of these, 2 and 3. And that looks to be good to go. So now that we've been assigned an IP address, we quickly want to start exchanging some traffic so that we don't go into RC idle state. So what I like to do at this point, since the server is going to reside on the UE side, I want to see that traffic change over time. So I'm going to go ahead and do Control B and then %sign to split my window here. And I can kind of start traffic for UE1 in this window server. And I can go over to this window and come back here and start it with the second one here. And notice the only difference here is the difference in the port numbers, right? So we'll come back to this to see the effects. Sorry, go ahead. Terminal 5. Looks like I have 6. Yeah, I ran the Python file and it connected. Don't press enter, just leave it running. And it'll take a couple seconds usually to do that. And I'm quickly exchanging some traffic so it doesn't go in that idle state. As you can see, UE1 is going to be our threat actor in this scenario today. It's a minimal way that we can show this threat. I've simulated a higher bandwidth than 10 megabits per second, that being 40 megabits per second. You can see that my UE2 is within that range. And once it's exchanging traffic in this sense, it's relatively stable at this point. You can take some time to deploy your SSX app.
So the idea here is once you started the 5G equipment, then you want to start.
So the core is already running. So the RAN's running. The UEs are connected now, and I've started to simulate traffic in the downlink. Yeah. So which one, sir? And this side? So this is where we started the core. Yep. And this is. Yep, I went to another window and exported and started my node B here with 20 megahertz. Yep. And just everything after this, so we've kind of tried to denote it terminal 3, 4.
So Joshua, we are
Yes.
using that zero MQ.
Yes. Yep. One thing to watch out for when you're using ZMQ, as you increase the number of UEs, obviously this is going to have a computational impact on your local machine. With this, I think we've done 7, 8 UEs connected before it kind of overwhelmed the PC.
So about 7 UEs per set.
Yeah, exactly. You could have another cell that's serving other users, of course. Yeah, on another machine for sure. Or you, I mean, you could, you know, it depends on how you connect your core to your GNBs, right? You can either have separate core networks that have their own independent slicing. There's many ways you could do it. But you're right, you can split the computational load by having 2 cells that serve their own users. If I had a bigger computer, I could get more than 7 or 8. You know what I mean? We're just limited to the computational element of the local. I tried on like a Ryzen 7. Yeah. Or you could just simulate lower traffic, right? You know what I mean? You don't have to exchange as much each time. So now that we have those UEs running, I'm going to create yet another window here. And I'm going to go ahead and start the onboarding process of this secure slicing xApp. Again, just before I start to onboard this xApp, I would ask you to reference this figure to kind of understand what's about to happen. Is that the SSXApp is going to be onboarded. It's going to start collecting these KPMs. Of course, we've already implemented our threat actor in the scenario, which is this UE with the higher bandwidth adjustment, and it's going to automatically happen. It's going to automatically choose, and I'll show you in the logs. It's automatically going to make the decision to secure this user. So again, very similar to what we did before, we need some variables exported in our shell that's going to help us with these curl requests we're about to make. Just be careful to copy this entire block here. And I'll just, that's all exported in my shell now. I'll just press enter after I did that. Okay. There's 3 commands here. 2 are required. 1 is optional, which is the middle one here. But this first one, it's actually going to create this context from this onboard URL. And this is what you want to see, the status of created here, right? The second one will list the charts, but it's optional. And then this third one is actually the command that will onboard this xApp from the container into this new real-time rig. So at this point, quickly, I'm going to do a kube control get pods -a. You can see at the bottom here, it's got its own namespace, and the SSXApp is running. And I'll use kube control to go ahead and start printing those logs. So here you can see some status of the xApp that was just onboarded, right? So you can see that the northbound interface hosted on localhost or 0008000 is open. That's ready to take those slicing indications from that JSON that I showed you earlier. We're going to leverage that just in a second to set up the scenario here. And generally, this is kind of what you want to see when you run this xApp. You want to see as far as something that's about to run and not, you know, cause any errors for you. So I'm going to create another window, but this log window is a very important window for us. I'm already in this SSXApp directory here. And if you notice, I'm going to chmod +x, which makes this script executable. I can see from my terminal that
if it's green, this means that it's ready to go for me. I'll kind of peek in there real quick again to kind of reintroduce you to the concept of this is where everything's going to, these commands are going to be sent over that northbound interface that are going to configure our slices for us. And in this scenario, we have one fast slice that both UEs are going to be operating in originally. And then if it's deemed malicious, it'll unbind it from that slice and rebind it to a slice with 0 resources. So after I run this, it's going to start making decisions. So I'll go ahead and run this. And as you can see in our standard out, it'll go ahead and list those for us in real time. And I want to go back to these logs, for instance, and you'll start seeing in this window KPMs from each of the users start printing. This is actually the ENB, so I can do a little bit better than this. So in this window, it goes by pretty quickly, but if you capture these logs, and I'll try to show you here, see these are KPMs from each of the different UEs. So we have a lot of different KPMs, right? We have TX packets and DL bytes and so on and so forth. And you see, based on this false positive that we talked about earlier, we loop over this 10 times, and then we make the decision to either unbind or continue with the slicing that we have. So this is going to give you a lot of good information of like how many resources per slice you have. Of course, we have a slice fast and a slice secure with no UEs operated in it yet. And as you can see here, I'll go ahead and quickly go back. The action was taken to secure that. So you can see that it now is effectively disconnected, right? It saw it as malicious, and the other one is still operating within its service level agreement. Okay. And I want to go back to these logs, and you kind of have to catch these because see, it'll continue, and it prints a lot of information. So if you don't kind of try to go up fast to catch it, you can kind of miss it. I know there's a way to search up in the terminal, and actually, if you notice, it printed so much in such a small amount of time that actually the buffer is full. But if I were to look at the logs, I saw it, but you can see that it actually tells you the decision to slice this UE outside of the fast slice was made, and it unbinded that. So that kind of concludes this demonstration of this xApp here. I would love to kind of personally kind of go with people and run this xApp itself. Yep. It was fully E2. Yes, there was a control message that was generated that was sent to the RAN that, of course, was received and yeah. So the O1, if I'm not mistaken, is primarily if you want to deploy the RIC in the cloud, right? Then you would leverage the O1 interface towards those RAN nodes from the cloud-based deployment, which is very nice. We don't currently in OAIC platform, as far as I'm aware, right, Pratik, have any xApps that have the O1 or anything like that. So, and I don't know of any platform that does actually. So.
Hmm.
This is kind of running, so I went to check the process. It's not there.
Oh,
Yeah, so there's no EPC running.
yeah. What was the error on that? Try to run the EPC again. Error initializing. Yeah, you're right. It definitely is running in the background. Can you do maybe top and then grep for EPC? Because we need to find that PID. And so here's SRSRN process. Maybe just kill that process, and maybe you can do a kill -9. And,
Kill -9.
yeah, I mean, you can send whatever signal. I think it'll work either way.
Just the PID.
Yeah, it should just be the PID. Yeah. You can also try sudo pkill and then the PID. I think that'll work too. But yeah, if you stop those processes, I think you're right. There's a process running. So yeah, of course.
So I'm not sure that this slicing
Yeah.
process at one time. This doesn't have memory resources, compute.
No, because that's different, right? So the resources that we're dealing with here are PRBs, right? Resource blocks. So we'll map those on to the different. Exactly. And you can actually specify the share in the slice, though, of the PRBs. So for instance, I have 1024 share in the fast slice and 0 in the other slice. And they'll kind of like, they do a proportion calculation based on, because they want to ensure a fair distribution of the resources, even still that it's operating within different slices. This is based on the MAC layer scheduler too. So, but yeah, actually, if you look at the source code, and maybe I can, since we have a little bit of time, I can kind of pull that up and kind of go through the main loop of this code and show you. But essentially what it is it calculates this PRB that's going to be sent over the E2 interface in a control request and updates the MAC with that calculated PRB based on the added intelligence of the RIC. And then that's the next PRB allocation that the RAN will use for that UE, right? So yeah, as far as like, you're right, there was some idea that I had as well. Like you can leverage the cloud native architecture to horizontally scale based on like, if you had many more users, you could, provision more resources in your cluster. Yeah, that's a great idea, but it's not relevant to this resource. So now that I've demonstrated it running, like I said, we can come around and help you run it. I think everybody should be very close to where they were going to run it. Is there any issue that I can troubleshoot myself with anybody to make sure? I want as many people as possible to run this and see what's happening here and understand it. The process is still. Yeah, this shouldn't be too bad of an issue to solve.
Does anyone else need help?
There's your E and B process. So your EPC is somewhere, man. Can you just do? I think with pkill you can just say SRS EPC, right? I think so. So just do sudo pkill SRS EPC and try it now.
Oh, crap. To SSH to.
Oh, okay.
Well, it's in there here.
Oh,
yeah, it is.
window.
With TMUX, it should multiplex over that SSH connection too, so.
Nice.
Got it?
Yep, got it, thanks.
Yes. Yes.
Hey, we need some question.
Sorry, one sec. Hey, yeah, one sec. I'll come right directly to you. What's up, Rick? Yeah, so this is a common issue. So we have to redeploy the RIC. So if you can go back to the instructions, I can kind of show you what to go back through. So go up. Yeah, go up a little bit. Yeah, go up. You don't have to recompile all this, don't worry. Go back up. Let's see. So you just want to run this command. No, hold on. You want to run this command, right? So you just want to stop all the processes, rerun that command, and then rerun it, and it should work. Okay? Yes, sir.
So it looks like the design kind of finds out there's
It's a little bit naive, let's be honest. You know what I mean? Like we're using a bandwidth allocation above 10 megabits per second to say that there's increased TX packet, which there is. If you capture these KPIs, you'll see that there was an increase in TX packets towards this RAN, right? A more effective approach to this attack would actually be generating some interface where we can, simulate the attack more realistically, right? And we do that with SDRs. But with the virtualized channel that we're working with here, this is the only way that we could come up with to effectively launch this attack. So actually, I had some feedback.
besides that this is suspicious. It limits the read rate and then doesn't leave there, right?
So because it's operating within a slice, we have the ability to move it to another slice that has no resource at all. So it updates the MAC and says, hey, don't give this guy anything. You know what I mean? Because it knows the MZ, right? So your question to me should be, okay, what if it's a rogue UE, so what? He can change his MZ, right? He can, try to gain access even without knowing his MZ,
No, my question is that whenever that you
Mm.
start sending packets in normal way,
Mm.
is it going to be out of that queue or is it still?
So it has no share of resources, so it can't do anything, right? Because it's trapped in this slice that has no resource at all. So yes, you're right. It's still technically connected, but as soon as that R state goes to idle, it'll be disconnected, right? Yeah. So there's a lot of work to be done. I think we've just started to scratch the surface of the potentiality of this mitigation strategy here. And obviously, if we incorporated the non-real-time RIC to fine-tune some, learning-based approach to the actions taken here, that would be even better. You know what I mean? Because right here, this scenario that we've put together here is based on a static threshold, right? So, and that wouldn't work in the real world, of course, because you don't know over time. This channel is way different from one time to the next. That's why we have the false positive that we had to deal with, right? So, but these are great questions. It looks like you understand, a lot about it. Yeah, keep asking questions. Though. Hey guys, how's it going? Everything going well over here? Yeah.
We're trying to, like, let's say, so basically you're doing the slicing of the RAM based on the, like, let's say the number of BS, something like that, and you do it proportionally, like weighted.
Yeah, so it's TDD, right? So like there's a calculated proportion. You're right. Like so every time slot it'll go to the next one that needs to be served, and it'll know that this UE is operating within this slice, so it should be given this amount of resources. Now that works in coordination, and that's why it's a little bit hard to explain, of the scheduler, the default scheduler of SRS, which as you know is a proportionally fair scheduler. It's going to try to distribute these resources evenly regardless of the
I'm
slice.
just trying to like map my mind around it. Is it possible like to to go a little bit deeper when it comes to RAM slicing? Like, are we taking into consideration, for example, the spectrum?
Hmm.
Would it be possible?
No, that's a great question. If we did it in frequency instead of time, that would obviously be great research actually, because you can use this to kind of like do some coexistence between the spectrum of many different users and many different cells, right? So that's something that we're thinking of. We want to do that, but unfortunately, this SRS version is actually the UE is limited to TDD. So that's the only reason we haven't, tried to do that as far as a research direction. That's a great research direction, though, actually. Yeah.
Would it be possible for us to code it on our own? Like,
You can.
we need
If
to go deep into the code base?
I don't, yeah, if you're at the part of your graduate studies where you're in SRS code base, it's a fun time for you because it's a very complex code base. We modify it ourselves, but the timing is obviously very strict. So if you start modifying things, it becomes very crashy, right? That's what we observed. Yeah, I would love to work on that functionality. Unfortunately, this SRS UE, they've completely dropped it. They say we're not going to work on it anymore at all ever again. They don't want to develop a UE anymore. So actually, the SRS Run project only has a GNB, and they don't even have a core network anymore. They rely on Open5GS, which is a great core network actually. Yep. Yeah, so you're limited by the computational complexity of your local machine, right? So when we're talking about this virtual channel, the more UEs I add on, the more impact I'm having on my local machine. On a relatively average PC, I've gotten about 7 UEs connected, and they all worked with the slicing and everything, right? So if you have a very powerful computer, I think it's as much as the computer could support, right? Because instead of the all the processing happen on the radio unit, it's all on your machine now, and that's multiplied by n, right? The number of UEs. So at some time you're gonna hit some CPU limit or exactly. I'll be interested to see how many y'all get running, because if I had a bigger computer, I'd do many. But it's all being served by one cell. So is it really interesting to add more and more UEs? I don't know. You know what I mean? It'd be more interesting to have multiple cells that have kind of like a coordinated slicing. So, anyways, interesting discussion, y'all. Hey guys, how's it going back here? How are y'all? Is there any questions I can answer kind of in this? Hey, hi, glad you made it. Awesome.
Where are you guys at right now?
We ran the demonstration, and I kind of wanted to just get in the crowd and kind of have some discussions about the xApp and kind of make sure everybody runs it and understands it and everything like that. So
Yeah, I guess.
I'm glad you made it.
Yeah.
Yeah. I saw your message. Is everything okay? And
Yeah, I made
okay.
it to the hotel. So,
Oh, great. Welcome to Mississippi.
Yeah, okay. It's good to meet you.
I'm thinking last year. So last year.
How's it going, everybody?
So I have one question specific for Mac.
Is this the new? This is so nice.
It's 10 Pro.
It's not supposed to be fingerprint, but it's so fingerprinty. You know what I mean? Yeah, no.
The question is, how do I Tmux?
Yes, Tmux.
How do I divide this so
Oh.
I can see everything?
So it's in the cheat sheet, but I'll just kind of can I do it? Okay, so I'll do Control B, and if I want to split it vertically, it's Shift and 5, right? Horizontally, I think it's this, but we'll have to reference. Yeah, I already pressed it, which is the Action key, and then Shift 5, which is percentage sign. So do the Control B one more time. Yep. And then you can Control B and use your direction keys to swap back and forth. Okay?
Okay, thank you.
Awesome.
Because they are used to Windows.
Oh yeah. Man, Windows. How's it going? Did everything run for you?
Yeah.
Okay.
Indeed.
Awesome.
So can you tell me about the setup before this xApp? Like you have one slice, right?
Yes.
And you have to use the slice.
Yes.
and you have 100 PRBs,
Yep.
and
Yep.
you are saying that like now the window that you decide when the user is malicious, like how many KPM do you take? Like in like 10?
So it's based on the TX packets that we're receiving from the user, right? Because we wanted to simulate like an overload of requests from the user's context for resources, like some kind of flooding attack, right? So we kind of just there's no scientific approach to the threshold that we made. It's static anyways, and we're looking to replace it, obviously. But we kind of just ran it a couple times and printed that metric when we simulated the higher bandwidth and said, okay, well, generally it's over. You can look at a legitimate UE and see that it's generally like horizontal, like it's always within this TX packets. And then we can like simulate this abnormal behavior from the UE with the higher bandwidth and say, okay, well, generally it's over this. So that's how we kind of dialed in the threshold. And it took a lot of manual work actually, because for each number of UEs that we wanted to do, we actually had to recalculate the threshold based on this, because it wasn't a linear increase actually. You would think it was a linear increase, right? But it's not actually. I don't know why. Yeah.
What type of KPIs did you use?
Sorry?
Or what type of KPIs did you use?
Oh, KPIs. Actually,
Only bandwidth or downlink bandwidth and
so for this threshold, we use TX packets, but we have many available to us. You know, we have RX packets, we have RX errors, TX errors, DL PRBs allocated, and uplink PLBs, all this kind of stuff, and many, many more. Yeah.
so based on this, we took the decision that the user is malicious.
Exactly. And there's huge potential to add your own custom metric, right? That's where it kind of becomes more interesting, in my opinion. Is like, can we facilitate new metrics? That's kind of when we were talking about this UE tester that we're working on. It's kind of like that's the goal of the project. Like, what new metrics can we introduce that could kind of kind of shape the specifications, like kind of update.
From the CU or the DU, like new data.
Well, there's not really any security-based metric, right? It's all like 3GPP, like based on the channel and stuff like this. But there's no real like, secrecy rate or any other metric that would tell me how secure this is. And I guess these metrics would probably have to be an aggregate of a lot of different analysis that happens, right? It can't just be one metric, like.
Have you considered like using machine learning because you have a lot of data, right?
We're actually doing that now. Yeah, exactly. And not for downsampling the data, which would be a good idea, but just to kind of like make a more intelligent decision, right?
Yeah, because you have so many KPIs, so maybe you can utilize these KPIs.
Yeah.
Instead of just taking one and say, okay, like this.
Yeah, you're right. There is every 10 milliseconds it generates a whole another report. You're right. So it becomes quickly overwhelming.
So can you configure this like this sample like every 10 milliseconds, or maybe you can say like every 20 milliseconds or every like 50? Can you configure it?
There's no knob to configure that, and actually 10 millisecond is the specification for ORAN for a timely E2 transfer. So yeah, you could probably make it more latent, probably, but I don't know why you would ever want to do that.
Let's say that I'm a user and I'm in a car and I have like a speed of 300 kilometers per hour and I want to do something with handover. So you need like low latency like samples, right?
Yeah, exactly.
So that's why maybe like I was thinking if I can configure.
Oh, can you make it faster?
Faster.
Oh yeah, I was like, why would you want to make it slower?
No.
Yeah, faster would be great, but it does take time to get those metrics too. I think I've done it. I've tried to make it a little bit faster, and I've observed that you can get like 6 to 7 milliseconds, but not any closer than that. I think it's primarily related to like SRSRAN, because basically SRSRAN is a big loop, right? So you're waiting for yourself to loop over all this massive code base. And actually 10 milliseconds is a long time actually to loop over just code,
Yeah.
And we're using an emulated channel here. Think about with the USRPs, we actually observe like 15, 20 milliseconds. And ORAN software community says, okay, that's you can actually use that data effectively to make near real-time decisions because it's outside of the time scale.
Yeah, of course.
All right.
Like until 10 seconds. Yeah.
So
is there a specific reason that you select this SRSRAN instead of OAI or maybe like SDRAM? There's so many like different.
I personally really like OAI, but I would say if you're not like if you don't love development and you don't like love coding, I would probably stay away from OAI. You kind of, it's very developer centric, like, so you kind of have to understand like how developers think about how they would want to write documentation is one big area that OAI has to improve is the documentation is very poor, you know. Um, they have an interesting relationship with ORAN software community now. So it's interesting to see how FlexRig's going to evolve. Now, as far as like any fundamental research into the near real-time RIC and this stuff, I would probably say ORAN software community RIC is probably the way to go because you get that container-based deployment. You have the added complexity, but depending on what you want to do, FlexRig is very simple to write these so-called xApps or but I don't know. They break the rules like this. They have the spec, and it doesn't conform to the spec. So I don't know if it's really a near real-time RIC or not. It's more of a RAN controller. I'll give it that. It's a RAN controller. So it's interesting. In SD-RAN, we actually recently tried to set it up, but also their documentation is very poor too.
Which one, like the AT?
SD-RAN.
And there's also AT. But this is more for
Yeah, that's what we tried to set up. Yeah.
like in one machine?
We could not work. We could not set it up. We could not get.
Oh, really?
Because as far as I'm aware, this is the only other slicing emulated setup, right?
Yeah, right. Because I deployed it before 1 week and it was easy.
It worked.
Yeah. Maybe it's like what type of hardware you have.
Man, I'm humble. I'm not the smartest guy in this room. You know what I mean? So if you have instructions on how to install it, please share it with me. Because we tried for probably 2 weeks to set up SD-RAN with slicing, and we just could never get it. So, but I do think though, even though we couldn't set it up, we kind of looked at the code level analysis of it, and it seemed like a very simple, like there wasn't a lot of features as far as the slices. So interesting. Maybe what you could do is you could use a combination of both. I don't know what your objectives are for research, but maybe you could like kind of, since it's all based on REST interface anyways, why can't you just do some of this and that? You know what I mean? Because I would also prefer to have a simulation before I validate it in a real test bed. This is more like towards a real test bed,
Still like you have a small scale test bed, right? You have like how many bits do you have upstairs? Like
So currently I've only tested with one, but like I said, I've gotten like 7 UEs working with it.
7 UEs with
Yeah.
1 Xenon B.
Yeah, with 1 GNB, yeah.
But let's say if you wanted to deploy a small scale network with 3 Xenon Bs.
That's what I really want, and that's why I want an emulator.
Yeah, but yeah. Okay, I see what you mean.
You're great. Yeah, you're on the same track of thinking as like, let's get an emulator. The community doesn't want to support it. The PhD students just saying, I just want the tool. So I think that's what's kind of nice about these projects is it kind of like facilitates in this project to build these tools out for everybody, right? So
I think that all of these softwares are not stable.
yeah, you saw how complex it is though. There's a lot of complexity to this. And the thing is, unless my objective is to make SRS-RAN stable, which it's not, why do I really care? You know what I mean? Like, that's a problem with wireless in general though, right? Like, the phones are the best example of reliability as far as this community I've ever seen. I had a phone connected for like 20 hours, exchanging like over 100 megabytes of bandwidth. That's a lot of bandwidth, yeah. And it was stable. I mean, the phone was scorching hot. Like I probably destroyed that phone.
What used to be?
It was the GNB side was a B210, and then I had a Pixel 7 on the other side. So, but yeah, if we can, I would love to work on something like this with you.
There are a lot of like different options like OEI.
Oh, there's so many. Yeah. OEI though, it's not a realistic option because the service model doesn't actually work with slicing. Yeah.
I've gotten slicing to work, but they have a very naive RAN simulator. Basically, you generate your own KPIs and put it in their simulator. And anyways, you know what I mean. Hey guys, how's it going? How are y'all? Oh, it's okay. Yeah. No, it doesn't necessarily depend. I mean, I think Yusashi, right? Yeah. Hey, good to meet you, Yusashi.
Nice to meet you.
I remember you from last year's workshop, but it's been a long
I
time.
was supposed to participate that time.
Yeah. So we're gonna probably have a dry run after everybody leaves, and we can work on it then. I think if you want to have them reinstall the stuff for yours, you're using a Docker container, so they don't really need all this setup. So if you want to tell them, hey, give me a new VM, that's fine with me.
Yeah, it's just like our container is almost like 12 GB, so I'm
Wow.
a little concerned.
Yeah. The Wi-Fi should be pretty quick. We had one
So it's taking
situation
like
here.
5 minutes. I'm running on Google Cloud. It's taking 5 minutes.
Oh wow.
But I'm concerned if they'll have the speed.
Yeah. We told them to provision it with 75 to 100 gigs, so I doubt that'll be a problem.
You try it out.
Yeah, we're gonna dry run it tonight and see. Awesome. Thanks so much. Hey.
You want to like stand up there and we take a picture for you?
I want a coffee.
You want a coffee? Coffee over here.
I want a coffee.
That's understandable.
The picture I can wait for. The coffee I can't wait for.
Oh, man in blue shirt. Who is?
Yeah, I don't know. He has some company. He has some company on wireless.
He came talk to me. So he's from Algeria.
Oh, cool.
So he came to me because I think that's what he needs to know where I'm. You know, he said he will give me his card.
Oh, great. That'd be great.
Yeah?
Yeah. I think he's
Thank you.
came here to learn.
I think
So.
so, yeah.
Any coffee over here?
Yes, there's new coffee here.
Oh.
That's it.
Shonda, thanks so much.
It's empty. We have the Chick-fil-A coffee.
Oh, wow. Wow, it's Starbucks and Chick-fil-A coffee? This is good. Okay, I want the not this one. Oh, okay. Gotcha. That's all right. Yeah, it went really well. Yeah, it went less smoother than I thought. I think so. Thank you so much. Appreciate that, Wall. Yes.
Just let me know when you're ready.
Haven't said anything bad. I'm not muted.
Are you going to do more on the screen?
I don't think so.